Hello everyone. Welcome back. Let me start with something fun. Imagine you're playing a game of hide and seek in a massive park. Your friend shouts, "I'm standing near the third lamp post, 2 steps to the right of the center." Instantly, you know where they are. That's exactly what coordinate geometry does. It gives every point in a plane an address. Now, think about this. Geometry has always been about figures and shapes. Algebra, on the other hand, is all about numbers and symbols. But coordinate geometry unites the two beautifully. We use an ordered pair, written as bracket open x, y bracket close, to represent a point. The horizontal line is called the x-axis, the vertical line is the y-axis, and they meet at the origin, which is O bracket 0, 0 bracket close. With this setup, suddenly we can study lines, parabolas, and curves using nothing but algebra. And you'll be amazed, this idea powers GPS navigation, engineering blueprints, seismology to track earthquakes, even computer graphics and art. So remember this, coordinate geometry is not just a chapter in math, it's the bridge between algebra and geometry. Let's now dive into coordinates themselves. Every point in the plane is located by two values. The first value is the x-coordinate, also called the abscissa. This tells us how far the point is from the y-axis. The second value is the y-coordinate or ordinate. This tells us how far the point is from the x-axis. For example, any point lying on the x-axis looks like bracket x, 0 bracket close. A point lying on the y-axis looks like bracket 0, y bracket close. The entire plane is split into 4 regions called quadrants. Depending on the signs of x and y, a point like bracket 2, 3 bracket close lies in the first quadrant, a point like bracket -3, 2 bracket close lies in the second quadrant, and so on. And here's the magic, just 2 numbers are enough to precisely locate any point in the infinite plane. Time for a fun activity. Imagine plotting a set of points, a bracket 4, 8 bracket close, b bracket 3, 9 bracket close, c bracket 3, 8 bracket close, all the way up to L bracket 5, 8 bracket close. Join them in order and you get a closed figure. Now, add small triangles using points P bracket 3.5, 7 bracket close, Q bracket 3, 6 bracket close, and a bracket 4, 6 bracket close. Do the same with X, Y, Z, and then S, T, U. Finally, extend lines from S and U to the y-axis at coordinates 0, 5 and 0, 6, and also to the vertical line x equals 9 at points 9, 5 and 9, 6. When you finish, surprise! You've drawn a meaningful picture out of just coordinates. That's the charm of coordinate geometry. Numbers on paper can come alive as figures. Now let's connect algebra to geometry. Take a linear equation in 2 variables, ax plus by plus c equals 0, where a and b are not both 0. The graph of this equation is always a straight line. Next, take a quadratic equation of the form y equals ax squared plus bx plus c with a not equal to 0. The graph is a parabola. So here's the big idea. Every algebraic relation in 2 variables corresponds to a curve. And conversely, the geometry of curves, their slopes, intercepts, turning points, can all be understood through algebra. This is why coordinate geometry is called a two-way bridge. Equations become pictures, and pictures become equations. So what's in store for us in this chapter? First, we'll learn the distance formula, which tells us how to calculate the distance between 2 points when their coordinates are given. Second, we'll explore the section formula, which helps us find the coordinates of a point dividing a line segment in a specific ratio. These may sound basic, but they're foundational. They prepare us for circles, conic sections, vectors, and even three-dimensional geometry. And the tool we'll use again and again is the Pythagoras theorem, the same one we studied in triangles, now applied in the coordinate plane. So think of this chapter as laying the foundation for all the advanced geometry you'll tackle later. Let's work out an example. Take points A bracket 4, 0 bracket close and B bracket 6, 0 bracket close. Both are on the x-axis. The distance AB is simply absolute value of 6 minus 4, which equals to units now. Take points C bracket 0, 3 bracket close and D bracket 0, 8 bracket close on the y-axis. Their distance CD equals absolute value of 8 minus 3, which equals 5 units. But what about a diagonal distance? Let's find AC. AC equals square root of bracket open 4 minus 0 close squared plus bracket open 0 minus 3 close squared. That equals square root of 16 plus 9, which is square root of 25, equal to 5 units. Notice how algebra confirms what our eyes see on the coordinate plane. Distances are no longer guessed, they are calculated. Let's bring it all together. In coordinate geometry, every point is an ordered pair x, y. The x-coordinate, or abscissa, measures distance from the y-axis. The y-coordinate, or ordinate, measures distance from the x-axis. Points on the x-axis have the form bracket x, 0 bracket close. Points on the y-axis have the form bracket 0, y bracket close. Equations in two variables draw curves, straight lines, parabolas, and many others. Coordinate geometry is our algebraic toolkit for solving geometric problems. So, the key idea, coordinate geometry is the language that turns numbers into shapes and shapes into equations. And with that, we are ready to move on. In the next video, we'll explore the distance formula, our very first tool in coordinate geometry. See you there.